Hey everyone, it's Mr. Anderson here. We're going to talk today about section 4.2.1 in our CPM Common Core Algebra book. And today our goal is to really do the deep dive on a very specific and niche item in the equal values method that we covered in one of our last lessons. But today specifically we're going to talk about substitution and when substitution is a good idea and why it works and how it can benefit us, especially if we know what we're looking for. All right. We spent time already in one of our last sections talking about the equal values method for solving, right? Taking two systems with two variables and then setting both of those things equal to the same variable, then subbing and then solving. And today, we don't necessarily need both of those things equal, but substitution will work for the exact same reason. And I've picked a couple of problems here that are really going to help us identify how beneficial this is, and maybe if we can remember that equal values method, we'll have a good grip on why it works. All right, check it out. We've got 4-32 here, and if it's not abundantly clear, you can see it right here on my notes, but you can also see it on the left-hand margin of our ebook here. We are in section 4.2.1, and we are going to use the substitution method. And this picture is a really, really nice picture that broadly demonstrates why when to use the substitution method and why maybe it's going to work. If you ever have a situation like the one that we have here, where you have one of the equations solved for one variable, the substitution method is going to be a very, very good candidate in terms of a process for solving. So, of course, other methods will work. Graphing will work. The equal values method will work. But this is going to be a pretty easy method to go ahead and get going. So let's take a peek at what we got. We've got two equations right here. I've got an equation y equals negative x minus 7. I've got another equation, 5y plus 3x equals negative 13. Okay, and we're asked a question here in part A. Okay, oh, I'm sorry, two equations, each one has an x and a y. They both have two variables. We're asked a question here in part A. If y equals negative x minus 7, then does negative 7 or negative x minus 7 equal y? That is, are we allowed to switch those two things from left and right to left of the equal sign? And the answer is absolutely. Okay, and whenever it comes to, and this is always true in mathematics, whenever it comes to, and I'm going to fall back on some very basic knowledge that we have, all right? Whenever it comes to an equal sign, or dealing with two expressions that equal to each other in an equation, we are allowed to, trade both of those sides without a consequence, the flip-flop. I think you're going to agree here with what I have. 3 and 2 make 5. Well, it's also the case that 5 can be broken down into 3 and 2. Okay? We have that ability to trade things from the left and right because they are equal values. And when we're given information like this right here, y equals negative 7, y equals negative x minus 7, sorry, then we can say the exact same thing, but in the opposite order. Negative x minus 7 equals y, right? That is going to be a true statement, okay? Well, let's use that to our advantage then, right? And that's what it says here in B. Since you know that y equals negative x minus 7, can you replace the y in the second equation with negative x minus 7 from the top equation? Why or why not? Yeah, this is the big idea behind substitution, right? We're trading that out because we know they are equal. It is a fair trade. It's equitable. We are not breaking any rules by doing that. All right, if you want to break that down in your notes, great. I'm not going to write it because I just said it. But the key is that if they are equal, we're allowed to trade those out to remove a variable. Now, we might have to do a little more work to simplify, combine like terms, distribute, etc., but it will make that solvable, and that's what substitution is used for the purposes of solving. Okay, part C then. After the substitution is done, it says, once you replace y in the second equation with negative x minus 7, you have an equation with only one variable as shown below. That is key for us. That is key. This is called substitution because you are substituting for or replacing y with an expression that it equals, right? Solve this new equation for x and then use the result to find y. in either of the originals. I'm going to show you a little trick here that maybe makes your life easier. But before we do, we got to solve. And we are going to use our standard normal steps and tricks and steps and tools and rules that we use algebraically to do some solving. I will start by distributing. All right. This becomes negative 5x minus 35, and then the plus 3x equals negative 13. All right, now it's time to put those like terms together. I've got a negative 5x, I've got a positive 3x. We assemble those, we got 2x minus 35, and that's equal to negative 13. All right, let me clear that x up a little bit. I'll then add 35 to both sides. There's nothing new here. These are things that we've been working on since chapter 2, even dealing with some of this in chapter 3. The 35s cancel. I get 2x equals. Now here's where you might need that calc. Okay, but this does work out to be 22. And then finally I divide both sides by 2. And I get x. Oops, sorry. X equals negative 11. My bad. Okay, so x equals negative 11. And when you're solving a system, you're allowed to solve. Sometimes they'll just say, hey, solve for x. But in this particular case, if they don't specify, we should solve for both x and y. We have x solved for. And solving for y is really just substituting. And there usually is a better option in terms of which equation to plug into. Let's remember that x equals negative 11, and I'm going to come back up here, and I'm going to say, okay, well, I'm going to rewrite this, but instead of writing in x, I'm going to put in, again, substituting what I know x is. X is negative 11, and now some simple math helps me out and helps me find what y is. Okay, y is going to be 4. So I've successfully solved this when I have identified what both x, let me slide that up so you can see it, when I've identified what both x and y are. Remember, during any part of this process, you are welcome to pause, copy, take whatever you need for your own notes. Let's look at a couple more examples, but before we look at a couple more examples, I want to show you some systems where substitution is going to be the clear front runner for my choice. In 4-33 from your textbook, we've got 4 problems, A, B, C, and D. We're not going to do all of them, but let me help you identify why substitution would be my preferred method here. Okay? In part A, you can see we've got 2 equations, 2 variables in each equation, x and y. But look at this first equation. I've got a variable all by itself. That's what we want for substitution. All right, I'm going to slide over. I'm going to look at B real quick here. In B, I've got 2 equations, the top one and bottom one. Each equation has x and y. But check out B. I've got a variable all by itself. That tells me I want to substitute. All right, let's keep going. Here's C. All right. Here's C, I've got 2 equations, still x and y, but in the bottom equation, I've got a variable all by itself. Again, substitution is going to be a very, very good opportunity for me to do here. All right, finally, let's check out letter D. Letter D, I've got 2 equations. I've got B and C in each equation. And in the top equation, I've got C all by itself. Again, substitution is going to be a very, very nice method, okay? And I'll start with A here, and it's going to go pretty quickly. And I think you guys are going to catch on. Anytime you want to substitute, identify the variable that's isolated in one of your equations. For me, the variable in the top equation that's isolated is y. So what I'm going to do is I'm going to rewrite the second equation without that variable. Notice, I've copied that thing almost perfectly, but instead of writing in the y, I put a blank in there, and now what I will do is I will take and I will sub in what I know y is equal to. I will sub in a 3x. And folks, now I can do a little math. 2 times 3x is 6x. And now I can take 6x minus 5x. And that, of course, is just the same thing. 1x equals 4. That's the same thing as just saying, well, get rid of that 1 if you want. That's the same thing as saying x equals 4. But if you stop here, you don't quite have it. Well, if you stop here, we still need to find y. So I will sub again, but this time I will sub in the 4 right here. Okay, and now I can say, well, y equals 3 times 4. Y equals, and check it out, I've got a system of equations that I've solved. I've got 2 equations, 2 solutions. All right, I'm going to do one more of these. All right, I'm going to fast forward from A, I'll bypass B, I'll bypass C, and I'll work on letter D. I've got C equals negative B minus 11. So what I'll do is I'll take the other equation and I'll rewrite it without a C in there. Okay? And what I'll do now is I will sub in everything that I know C to be equal to. Check it out, I circled everything, negative B minus 11. Next step is going to be to do the distribution and be sound with your math here. 3 times negative B is negative 3B. 3 times negative 11 is negative 33. And 6 equals 6B. Now combine your like terms. Negative 33 and, well, let me rewrite this first. Negative 33 and positive 6 makes negative 27. And now let's add 3b to both sides. Over here we get some canceling, and we have negative 27 equals 3b and 6b makes 9b. Finally, let's divide by 9. I am going kind of quick here. Sorry about that. When we do this division by 9, I get b equals negative 3. All right. I maybe showed a little bit more work than you might have, but we don't want to sacrifice the process. All right, next, ladies and gents, we're going to take this, we're going to plug it in to the top equation because C is already isolated. Okay, I'll plug it in right there, but what is B again? Oh yeah, B is negative 3, and now I just have to make sure I got sound math, right? So C is negative, the opposite of negative 3, which is positive 3. And then we take away 11. Calculator will tell you, if you don't trust me, that that is negative 8. So check it out one more time. 2 variables, 2 solutions. All right? A couple more that you guys could maybe check out here if you want. Pause the video right now and give these things a shot. And if you hang out for 1 second and then unpause the video, I will reveal to you my solutions for B and C. All right, let's see how you did here. Here's letter B. I went ahead and I subbed in that x minus 4 into the bottom equation for y. Then I distributed, then I solved. I didn't necessarily show all my work, but I promise it should be very, very followable for you. I got x was 3, and then I took and I plugged in x equals 3 into that top equation. Instead of x minus 4 equals y, it's 3 minus 4 equals y, and y is negative 1. All right, last one. I solved it for you, and I want to point out specifically what happens. The last one was letter C, and check it out. Okay, when I subbed in that stuff into the the top equation, I took the stuff from the bottom, x equals 3 minus y, and I subbed it in. Check out what happens. I got my y's to cancel, and I got 6 equals 18. That's a situation where I'm not going to have any solutions. We know 6 doesn't equal 18. All right, not going to end up in a scenario there where we ever get that to be true. So that's one of those we got to be willing to say at that point, no solution when you end up with something false mathematically. All right, obviously there's check options. You could plug these in. You could plug in x, you could plug in y. Make sure you're plugging them into both equations to do some solving, right? We also, and you've seen this already, only very briefly, but we're going to be moving into this space, we also have the ability to graph to check these things, okay? So ladies and gents, don't forget to check your answers, because checking and moving forward with confidence is important. But otherwise, we've got a little bit of review preview here, and the review preview is at the bottom of the page. It's just a couple questions. These are pretty bare bones, and I think they are very, very doable. They're going to hit home on some very important things that allow you the opportunity to try some of these things out and ask questions if you have them. Ladies and gentlemen, thanks for watching. Have a great day.